Hello all. In the last video we have discussed about uniform velocity of the follower. In this video we are going to discuss about uniform acceleration and deceleration. Why we need to use both uniform acceleration as well as deceleration in only one case? Because if you are using only uniform acceleration, normally if you see the follower, when the follower is at its lowest position, it is having zero velocity. When the follower is at its highest position, it is again having zero velocity only. So when the follower is moving from its lowest position to highest position, at the highest position it should have zero velocity, and if you are using constant acceleration, the velocity of the follower is continuously increases, and as it reaches its highest position the acceleration is constant, so velocity is very high, so the follower will not stop there. That's why we have to use both uniform acceleration and deceleration. If you see here, during first half of the motion the follower is at constant acceleration, during next half of the motion the follower is at constant deceleration. So in order to obtain velocity and accelerations of this follower, we are using this equation s is equal to ut plus of at square. In this u is 0, initial velocity of the follower is 0, so s is equal to half at square. From this you can obtain acceleration of the follower in terms of displacement and time. Acceleration is equal to 2s by t square. So how to get the acceleration is constant at any point, so I am calculating the acceleration of the follower at the midway of the follower movement. So I am calculating the displacement. I am taking the displacement s is equal to h by 2. So I have to take the time also similarly. This is the equation we are obtaining from w is equal to theta by t. Angular velocity is equal to angular displacement by time, rate of change of displacement, rate of change of angular displacement. So we are calculating the acceleration at midway, so that's why I am using h by 2. So here the total angle is the angle of ascent, that is pi a, and we are calculating at midway, so I am using here pi by 2. So w is equal to pi by 2 by t. If I write in terms of time, I am getting t is equal to pi by 2 by w. If I substitute this s and t in this equation, I am getting acceleration of the follower. Acceleration of the follower is 4h omega square by pi square. Acceleration is equal to 4h omega square by pi square. So here we can also get the velocity. How to get the velocity? Velocity is nothing but first derivative of the displacement. V is equal to ds by dt, rate of change of displacement. So d by dt of s, d by dt s, we already know s is equal to half a d square. So if I substitute half a d square, I am getting v is equal to acceleration into time. So this is in terms of a and t, and to obtain, so I already know the a is equal to 4h omega square by pi square, so I have substituted the a value here, and t value we already know, we have substituted here pi by 2 by w, this is the t. So a into t is the velocity. If I cancel out the terms, I am getting v is equal to 2h omega by pi. So remember these two equations, one is v is equal to 2h omega by pi and a is equal to 4h omega square by pi square. We have to calculate velocity and acceleration in some cases. And how to draw the displacement diagram? We already know that the displacement is a parabolic. So from 20 degrees to 160 degrees it is parabolic, and from 160 to 200 degrees it is 0, it is a straight line, and from 160 degrees to 240 degrees again it is parabolic curve. And similarly velocity, here acceleration is constant. If acceleration is constant, velocity will continuously increases, that means linearly increases. So the slope of velocity is constant. Acceleration is constant means the slope of velocity is constant. So from 20 degrees to 90 degrees the velocity is increasing because it is constant acceleration. From 90 degrees to 160 degrees the velocity is continuously decreasing because we are using constant deceleration. Again, from 200 degrees to 270 degrees it is constant acceleration only. The velocity is continuously increasing in the negative direction. From 270 degrees to 340 degrees the velocity is decreasing. And similarly we can also obtain acceleration diagram also. If you see from 20 degrees to 90 degrees, the acceleration is constant and positive, uniform acceleration. From 90 degrees to 160 degrees, the acceleration is constant and negative, uniform deceleration. Deceleration means negative, acceleration means positive. From 200 degrees to 270 degrees, it is constant acceleration, but it is constant acceleration in the negative direction. From 270 degrees to 340 degrees, it is constant deceleration in the negative direction, negative into negative, positive. So this is all about constant acceleration and deceleration. And in the next video, we are going to discuss about simple harmonic motion. Thank you.